Hello Year 10. Today we are going to be solving quadratic equations using factorising. But before we do that, let's quickly review the completing the square that we learnt last lesson. When factorising by completing the square, you keep the first two terms, x squared minus 12x, then you halve the 12, which is negative 6, and square that. So negative 6 squared is 36. Now, adding a 36 into my expression, I need to compensate for that by subtracting it off again, and then I still have the plus 10 sitting on the end. Now, I need that plus 36 because those first three terms make a perfect square, and I can factorize them to be x, and if I halve the 12, I get negative 6, x minus 6 in brackets squared. Then the minus 36 plus 10 makes a negative 26 on the end. I can factorize that further by doing a difference of two squares. So the x minus 6 will be at the start of each bracket, and the square root of 26 will be at the end of each bracket. One will be a plus, the other will be a minus, and that is now factorized by completing the square. Question 2 is a harder version of this because I have a number in front of the x squared. All I need to do is factorize that out. So factorizing the 4, I will get x squared minus 2x minus 4. And then I will complete the square inside that bracket. So I'll take the first two terms, x squared minus 2x, halve the minus 2 and square it, so that makes minus 1, and minus 1 squared is a plus 1. Straight away subtract that off again and have the minus 4 sitting on the end. So the first three terms are going to make my perfect square. So before bracket, half of minus 2 is minus 1, so it will be x minus 1 squared, and then minus 1 minus 4 makes a negative 5 on the end. Then I still have a difference of two squares within that bracket, so the 4 is still going to sit out the front, and I'm going to factorize the difference of two squares. X minus 1 will go at the start of each bracket. The square root of 5 will go at the end of each bracket, one a plus and the other a minus. So hopefully you remember doing that last lesson. Let's go on with our new work, which is solving quadratic equations. Now, to solve quadratic equations, you need to be able to factorize them. And we've already spent time in previous lessons learning how to factorize things. So we'll be doing that again today. And then we use what is called null factor law to solve the quadratic equation. So here are the steps that we're going to follow. First of all, number 1, make sure that the right-hand side of the equation is equal to 0. So to use the null factor law, it always has to be equal to 0 somewhere. Then you're going to factorize or take out any common factors and completely factorize the expression. Then you're going to use null factor law to solve, to find the solutions, which is number 5, solve the linear equation. Now, the null factor law tells us that if we multiply two things together and it equals 0, that one of those things must be equal to 0. So either the A equals 0 or the B equals 0. So when it comes to having something factorized like this, that means the two things that are multiplied are my two brackets. So either the x minus 2 equals 0 or the x plus 5 is equal to 0. And I can solve each of those equations to get x equals 2, and for the other one, x equals minus 5. So that little bit there, that's the null factor law that we're going to be practicing today. Okay, so here are our questions. We're going to go through all the different types of factorizing again. Question number 1, solve the following using difference of two squares. So factorizing first, x squared minus 4 will be x minus 2x plus 2 when we factorize it. Then using null factor from the first bracket, either x minus 2 equals 0 or the x plus 2 is equal to 0. Solving that first equation, we get x is equal to 2. Solving the second equation, we get x is equal to minus 2. Now, if you've done this before, you may go straight from this line to this line as long as you understand the concept. Let's try again in part B. This is also a difference of two squares, so when I factorize it, it will be x minus root 15, x plus root 15 equals 0. So either the x minus root 15 is equal to 0, which means that x is equal to root 15, or the x plus root 15 is equal to 0, which means that x is equal to minus square root of 15. Question 2. We're going to solve by taking out a common factor. So I can bring out a factor of x from this, which will leave x minus 7 equals 0. Now from null factor, from the x out the front, I'm either going to get x equals 0, or from the bracket, I'm going to get x is equal to 7. So I'm starting to shortcut that method. In part B, I need everything to be on the left-hand side first. So let's move that minus 5x across and become a plus 5x equals 0. Then I can factorize an x out to give 3x plus 5, and then I can use null factor. So from the x out the front, I get x is equal to 0, or for this second one, it's a bit trickier, so I'll do the long method. We do 3x plus 5 equals 0, which means 3x is equal to negative 5, x is equal to negative 5 over 3. Question 3, we're going to use the cross method, which is for the monic trinomial. So we are going to look for two things that times to give the 3 and add to give the 4. That would be 1 and 3. Then I can use null factor. From the first bracket, I would get x is equal to minus 1. From the second bracket, I get x is equal to minus 3. Let's try that again for part B. What times is to give 3 and adds to give a negative 4? That would be negative 3 and negative 1. Using null factor, I get L is equal to 3, or x is equal to 1. Question C. What times is to give negative 20 and adds to give negative 1? That would be negative 5 and a positive 4. Then using null factor, I get x is equal to 5 from the first bracket, and from the second bracket, x is equal to negative 4. Part D, so lots of repetition here. What times to give negative 15 and adds to give negative 2? It's negative 5 and a plus 3. Then using null factor, we get x is equal to a positive 5 from the first bracket, and x is equal to a negative 3 from the second bracket. In E and F, we need to make sure these are in the right form first before we can factorize. So for E, I have to move the 6 across so that it's x squared minus 5x minus 6 equals 0. Then I can factorize by finding two numbers that times to give minus 6 and add to give minus 5. So that's minus 6 and a plus 1. Then I use null factor to get x equals 6 from the first bracket and x equals negative 1 from the second bracket. F looks like it's already factorized, but unless the right-hand side of my equation is equal to 0, I can't use null factor. So I have to expand this first, x squared minus 3x, and move the 10 across, so minus 10 equals 0, so that I can factorize it properly. So I'm looking for two numbers that times to give negative 10 and add to give negative 3, so that's negative 5 and a plus 2. Then using null factor, I get x is equal to 5 from the first bracket and x is equal to negative 2 from the second. Question 4. solve the quadratic equation. So these are the non-monic ones. So I'm going to split the middle term. I do 2 times 1 is 2, and I'm looking for two numbers that times to give 2 and add to give 3, which would be 2 and 1. So I'm going to split the 3x in the middle to be a 2x and a 1x, the 2 and the 1 that I found. Then I take the first two terms, factorise out a 2x, which would be x plus 1. And then the third and the fourth term is already an x plus 1, which means I can take the x plus 1 out as a common factor and have 2x plus a 1 that would be hiding in front of that second bracket to factorise it. Then, using null factor from the first bracket, I get x is equal to negative 1. From the second one, because there's a few more things there, we might want to do 2x plus 1 equals 0, and then solve it the long way to get x is equal to negative a half. Part B, times the 3 with the minus 2, which is negative 6. We are looking for two numbers that times to give negative 6, but add to give 5. And the answer would be a positive 6 and a negative 1. So we want a plus 6x and a negative x. That's splitting, this middle term is splitting into those two. And then I can factorise in pairs. So from the first two terms, I'm going to bring out a 3x to give x plus 2. The third and the fourth term, I'm going to factorise out a minus, which will also give me x plus 2. Then the x plus 2 comes out as a factor, and I would get 3x minus 1, because there's a 1 hiding in front of that bracket, is equal to 0. Then using null factor, I get x is equal to minus 2 from the first bracket, and from the second bracket, I get x is equal to 1/3. Question C. We do 5 times minus 8, which is negative 40. I'm looking to split this middle term. I need to find two terms that times to give negative 40 and add to give it positive 18. So 20 times 2, if it was a minus 2, positive 20, and a minus 2, then that would make a positive 18, and still times to give negative 40. The minus 8 is still sitting on the end, and now I can factorise in pairs. So from the first two terms, 5x comes out the front, and I get x plus 4. From the third and fourth term, I bring out a negative 2 to also get x plus 4. Then the x plus 4 is a common factor, and 5x minus 2 goes into another bracket. Then using null factor, I get x is equal to minus 4 from the first bracket, or from the second bracket, you would move the 2 over and then divide the 5, so it's negative 2/5. Question 5. Just to put something different in here, we've got decimals in our quadratic equation. Don't try to factorise why there is decimals in there. Try to times by either 10 or 100 to get rid of the decimal places. So because my some of my numbers in here have 2 decimal places, I'm going to multiply this whole thing through by 100, because that will get rid of them. 0.01 times 100 is just 1, so it's just x squared. 0.12 times 100 is 12x. And then 0.2 times 100 is 20, and it's still equal to 0, because 0 times 100 is 0. Now all the nasty decimals are gone, I can factorise this as normal. What times is to give 20 and adds to give 12? That would be a 10 and a 2. Then using null factor, I get x is equal to negative 10, or x is equal to negative 2. Question 6, so let's just have a few questions where we need to rearrange them. So I need to expand this one first. I'll have 4x squared minus 6 is equal to minus 23x. Now putting my quadratic in order, I have 4x squared. It'll become a plus 23x when I move it across. Minus 6 equals 0. So I have a non-monic quadratic here. So I times the 4 with the -6 to make -24. I'm looking for two numbers that times to give -24, but add to give 23. So that would be a positive 24 and a -1. So I split the middle term, and now I factorize in pairs. So first and second term, I can factorize out a 4 and an x, which will leave x plus 6. Third and fourth term, I can factorize out a minus, which will give x plus 6. Then I can factorize out the x plus 6, which will give a 4x and a -1 from that second bracket. And then I can use the null factor law to get x equals -6 from the first bracket, or x is equal to 1/4 from the second. Part B. To get rid of the fraction, I'm going to times the x up to the other side. So that would be x plus 12 is equal to x squared. Now I want the x squared positive, which means I'm going to subtract the x and subtract the 12 over to be on the same side. So it's equal to 0. Then I can factorize. This is just a monic one. So what times is to give -12 and adds to give -1. That would be a -4 and a +3. So times, using null factor, I would get x is equal to 4 from the first bracket and x is equal to -3 from the second. Question 6. Again, because I have a fraction here, I need to multiply the denominator over to the other side. Now that does mean I'm going to need to use brackets. The x needs to multiply all of the x minus 2, which would expand out to be x squared minus 2x. So the x squared minus 2x is the start of my quadratic. I move the -1 over to become a +1 so that it's all equal to 0. Then I factorize. So what times is to give 1 and adds to give -2 would be -1 and -1. Now that is x minus 1 all squared. But because the bracket is the same, we're only going to get one solution, which is that x is equal to a +1. For part B, because I have a fraction on both sides of my equation, I'm going to cross multiply. So the x is going to times with the x minus 2, so I'll need brackets for that, and the 3 times is with the 5 to get 15. Then I expand to get x squared minus 2x and move the 15 over to be -15 equals 0. Then looking to factorize, what times is to give -15 and adds to give -2. That would be a -5 and a +3. Using null factor, we would get x equals 5 or x equals -3. Okay, that was a lot of things to go through. Your turn to practice in exercise 5G.